If the zero-order correlation coefficient between two regressors is high, example larger than 0.8 in absolute value, we can suggest that there may be a problem of multicollinearity. But note that high zero-order correlation are a sufficient but not a necessary condition, meaning that multicollinearity may still exist even though the zero-order correlations are low. So when we talk about zero-order correlation, we are referring to the correlation coefficient only between two regressors. Example, if we have three regressors, x1, x2, and x3, when we talk about zero-order correlation coefficient, we are referring to the correlation coefficient of x1 and x2, x1 and x3, and also x2 and x3. This is an example of y regress on x2, x3, and x4. So there are three independent variables, and suppose that x4 is having an exact linear combination of x2 and x3. So if x4 is perfectly collinear with x2 and x3, then the R4 to 3 is going to be equals to 1, or R squared 4 to 3 will be equals to 1. So R squared 4 to 3 meaning that x4 regress on x2 and x3, and the R squared is equals to 1, which is the coefficient of determination. So the formula for R squared 4 to 3 is given here. So if you look at the formula, it consists of the zero pairwise correlation coefficient, whereby it has R42, R43, and also R23. So R42 is referring to the correlation coefficient between x4 and x2. It's the pairwise correlation coefficient. R43 is between x4 and x3. R23 is between x2 and x3. So suppose that we are having R squared 423 equals to 1, meaning that it's an exact linear combination. So the left side is going to be equals to 1, but the right side here is still going to be equals to 1 if we're having R42 equals to 0.5, R43 equals to 0.5, and also R23 equals to 0.5. So meaning that even though the pairwise correlation coefficient, so meaning that between x4 and x2 is very low, 0.5, correlation between x4 and x3 is low, 0.5, correlation between x2 and x3 is low, which is 0.5, still we can have a perfect multicollinearity whereby R squared 4 to 3 is going to be equals to 1. So therefore we can say that high pairwise correlation coefficient is a sufficient but not a necessary condition to show the problem of multicollinearity. So note that if the model consists of only two independent variables, then the zero order correlation will be just fine, will be okay to see whether there is an indication for the problem of multicollinearity. But if the model consists of more than two explanatory or independent variables, then the zero order correlation is not enough. You need to see further.